Okay, some more problems from section 4.3, and all we had to do was find the intervals on which the function was a concave up or b concave down, and that's just the second derivative test, so it's pretty easy. Our first derivative, we got a nice cubic polynomial here. So just take the first derivative and you get 12x squared plus 42x plus 36. Then take the second derivative, take the derivative of that, and you get 24x plus 42. And we got to check for our critical values, and that's going to be when the second derivative is either equal to 0 or undefined, the same thing. Okay, well, it's not undefined, it's just a polynomial, that's just a straight line. But it's equal to 0. If we solve for x, we subtract 42 from both sides, divide by 24, reduce it by 6. 6 goes in there 4 times, so you have negative 7/4. So that's going to be the critical number. We don't really need the y value because we're not trying to find a point yet. We're just trying to find the interval. So if we use our second derivative test, we just draw our line here. We put our negative 7/4 there. That's the x value, okay, of our critical point. And we look to the left, and if we put negative 2 into this derivative, we get negative. We put 0 here, we get positive, so we can see we have negative positive. So it's concave down and concave up. So it's concave up from negative 4 to infinity. I'm sorry, negative 7/4 to infinity, pardon me, negative 7/4 to infinity. And that's concave down from negative infinity to negative 7/4. So that's pretty easy. Okay, number 9. Okay, and again, all we do is take the second derivative. So if we look at this function, 2x to the 1/5, I hope you can read that, but it's in your book. Okay, if we take the derivative, is plus 3, the 3 is 0, the derivative of 3 is 0, and this just becomes 1/5 times 2, which is 2/5, x to the n 1/5 minus 1 is negative 4/5. We take the derivative of that, so we have multiplied negative 4/5 times negative 2, we get negative 8 over 25, x to the negative 9/5. Subtract 5/5 from 4/5, you get 9/5. So this is our second derivative, and we check it to see where it's 0 or undefined. Okay, it's not going to be 0 because the numerator must be 0, and that's not going to happen. It's 8, but it's undefined when the denominator is 0, and that's when x is 0. So there's my critical value. And again, I can just check my fraction, my fraction over here. Okay, this is going to be negative. I can think at the top is negative. If I put a negative 1 in here, since these are odd numbers, this would be negative. So I got negative over negative, which is positive. And then when x is greater than 0, I can try 1. So I can take the second derivative of 1. If I put a positive 1 in here, I've got a negative over a positive, which is a negative. So basically, I'm concave up from negative infinity to 0 and concave down from 0 to infinity. So those aren't too bad. We have another one of those, number 11. Now don't let the piecewise function value up. When you take the derivative of a piecewise function, you just take the derivative of each little piece. All right, so this was number 11. And again, we just take this was our function, it was 2x at x less than 1, and 2 minus x squared when x is greater than or equal to 1. Okay. And we can just take the derivative and take a look at what's happening here. If we look at the derivative here, the derivative of 2x is going to be 2, and the derivative of 2 minus x squared is going to be negative 2x. Now, this is not a continuous function at this point. I mean, if you put 1 in here, you get 2. If you put 1 in here, you get 1. So there's going to be a point of discontinuity. So we really don't have a derivative that exists at 1. So that's why we don't have anything going on here at 1. Okay? But we can still check the concavity and see what's going to happen. Now, if I take the derivative of this left part, okay, I've got 0, and if I take the derivative of the right part, I've got negative 2. But my 1 was a point of, discontinuity, so that's basically a critical point, so that's where it's not defined. So let's just see what's happening. So if we look at to the left of 1, when x is less than 1, we got 0 for the second derivative. So we don't have any concavity. That's a straight line, so it's not concave at all. There's no concavity, not up or down. Okay, so we would graph it like this. Now if I look to the right of 1, I have -2. It's always negative, so that's easy. And I'm concave down. So basically we're concave up to the left of 1. I'm sorry, concave up, no intervals. So the intervals are none. So to the left of 1, concave up, none. To the right of 1, concave down, yes, it's concave on this interval. I'm sorry, excuse me. The question was, where is it concave up? It's not concave up. Pardon me. Question is, where is it concave down? It's concave down from 1 to infinity. Sorry. I wrote this down so you could kind of see what the question was, and then I was thinking, it was part of the solution, though. This was the question. Where is it concave up? On what interval is concave up? No interval. The interval is none. There aren't any intervals. It's not concave up. Okay, what are the intervals where it's concave down? 1 to infinity. Okay, sorry about that. So hope that helps.